In this example, we're going to start by looking at our benchmark value to start off with, which is a value of 117.589. It will be entered in under our reduced level value. And under the remarks column, we can put in a quote of datum or benchmark. At the same point where we know the reduced level, we have taken a staff reading of 1.274. This is the first reading taken at station 1, therefore will be a backside. Next reading taken is at point A. It is an intermediate sighting. Its value is entered under the IS column, 1.180. Next reading taken is at point B. It is also an intermediate reading. The value is 1.801. Next at station C, this is the last reading taken when the level is at station 1. Under remarks, we can fill in the value of C, and under the foresight column, we enter in the value of 2.055. A change station now occurs where the level is moved from station 1 to station 2. A double reading is taken at station C after the level has been repositioned. In this case, the second reading, which is 0.836. This is the first reading taken at station 2 when the level is at station 2, and on the same row, fourth row, we enter in the value of 0.836 as our backside reading. Next value is recorded is at station D. It is an intermediate reading, 1.150. The next reading is at point E. It is also an intermediate reading. The value is 1.824. It is recorded under the intermediate column. Point F. Its value is 2.502, another intermediate reading. Point G. Its value is 2.736, again another intermediate. Point H. Also an intermediate, 2.876. Point I. Its value is 2.376. After point I comes point J. The value is 2.625. Point K is next. Also another intermediate, 2.870. Point L. its value is 3.237, also an intermediate. Next one is point M, 3.361, also an intermediate. Point N, 3.749. After point N comes point O. It is also another intermediate, 4.076. Next point is point P. This is the last point taken, or reading taken, at station 2. Therefore, its value will be a foresight, 4.316. A change station occurs, the level is repositioned, 2 readings are booked at point P, level is reset to station 3, so the first reading at station 3 is recorded. It will be a backsite. The value is 0.280, recorded as a backsite on row 17. Next reading is for point Q. It is an intermediate reading. Its value goes in the intermediate column. And finally, the last value recorded is at point R. This will be a foresight. The value is 1.644. Now all the values have been correctly entered into our booking sheet, completing the backsite, intermediate site and foresight columns. The next stage will be to calculate the difference between subsequent values and to enter that value into either the rise or fall columns. For rise and fall calculations, we consider the first 2 readings, work out the absolute difference, which is 0.094. Consider if the second reading is larger or smaller than the preceding reading. In this case, it is smaller, therefore the absolute difference goes under the rise column. Consider the next 2 readings, work out the absolute difference. The second of those 2 readings is larger, therefore the difference goes under the fall column. Next 2 readings, work out the difference. The second of the 2 readings is larger than the preceding one, therefore the difference goes under the fall column. Now a change station has occurred, so we reset the reading we use at point C and use this one under the backside with the next reading taken, which is the intermediate, at point D. Work out the difference. The second reading is larger than the preceding one. That represents a fall. Consider the next 2 readings. Work out the difference. Second reading is larger than the preceding value, therefore is entered in under the fall column. Consider the next 2 readings. Work out the difference. The second reading is larger than the preceding one, therefore it is a fall. Next two readings, work out the difference. The second of the two readings is larger than the preceding one. Again, another fall. Go again, next two readings, work out the difference. Second reading is larger than the preceding reading. Again, another fall. Next two readings, work out the difference. The second reading is now smaller than the preceding reading, so the difference goes under the rise column. Next pair of readings, work out the difference. The second reading is larger than the preceding reading, so this difference goes under the fall column. Next two readings, work out the difference. Second reading is larger than the preceding reading, another fall value. Next two, work out the difference. The second reading is larger than the preceding reading, so another fall value. Next two readings, work out the difference. Second reading is larger than the preceding reading, therefore the difference goes in the fall column. Next two readings, work out the difference. The second of the two readings is larger than the preceding reading, therefore this difference again goes into the fall column. Continuing on, next two readings, work out the difference. Second reading is larger than the preceding reading, another fall. Next two readings, work out the difference. The second of the two readings is larger than the preceding, therefore the difference again goes into the fall. A change station has occurred, so the reading that is used at station P is reset. The 0.280 is used with the next reading. Work out the difference. The second reading is larger than the preceding reading, so another fall. Next two readings, work out the difference. The second reading is larger than the preceding reading, another fall. The difference goes under the fall column. The rise and fall columns have now been completed for the set of measurements. To work out the reduced level at each of the points, we start with our first reduced level and either add on a rise value to calculate the next reduced level or subtract a fall value to work out the reduced level. In this case, for point A, we have a rise, so we add this value to our current reduced level to get 117.683. Next, we have a fall, so we subtract this from our current reduced level, 117.062. Next, we have another fall, so we subtract that from our current reduced level, 116.808. Again, another fall, subtract this value off, 116.494. 4. Next value is another fall, so subtract this value from our reduced level, 115.820. Another fall. That gives us a value of 115.142. Another fall. 114.908. Another fall value, so we subtract this off, 114.768. Then we have a rise, so we add 0.5 to our current reduced level, 115.268. Then we're back to having a fall, so subtract that value off. 115.019. Another fall value. Subtract that off. 114.774. Another fall value, subtract that from our current reduced level, 114.407. Another fall value takes us to 114.283. Another fall value, and we get to 113.895. Another fall value, 113.568. Another fall value, 113.328. Another fall value, 112.538. And finally another fall value, subtract that from our previous reduced level to give us a final reduced level of 111.964. Our reduced level column has now been completed. To complete our numerical checks to verify the calculations that we have just completed, we add up all the backside readings. We get a total of 2.390. We add up all our foresight readings. We get a total of 8.015. The total of the backsights minus the foresights gives us a value of minus 5.625. Next, we add up all the rise values we have. That gives us a total of 0.594. We add up the total of all the fall values that we've calculated. That gives us a total of 6.219. The total of the rises minus the total of the falls gives us minus 5.625. And finally, we take the last reduced level, and from that we take away the first reduced level. If you work out that difference, you also get minus 5.629. Our three numerical values we've worked out are identical. That gives us confidence that the calculations we have just processed are correct.